Hello, I'm Muhammad Karuna Tamim Azman, and I'm in charge with the LCD connection and LCD coding. So first, how do I turn from a blank LCD monitor to showing variety of information? First, in the coding, we need to include the liquid crystal library to make sure that we can use the commands in our coding. So first, we need to use lcd.init and the bracket to make sure that our LCD is turned on. Then we use the clear LCD clear to clear the screen so that if there as in Arduino we are looping through looping, so pass information is could be there. So we need to clear it so pass information will not interrupt our display. Then we will set the LCD set cursor 00 is the way the command that we use to format our LCD as we have 16 rows, 16 columns and 2 rows. With the 16 column, we start with 0 until 15, and then 0 until 1 for the row. Okay, so we set as the set cursor 0, I mean we start at the top at here. Then we print out temp, which is 5 characters, and we use 0 until 4 format. And then we set the Celsius to be printed on 5. And then we use the set cursor at 1, which mean auto here. We use 8 because we want to make sure there's some gap between it. Between the auto 8 mean the coordinate column 8 and then row 1. And we use set cursor 01, which is here to print humid, and then we use 80 to print bright here. So that's all from me. I will now pass to the next, as I am the final. I will now pass to the next person.
My name is Arif Azizi Bidiwari, and I will be explaining on the sensor integration for the temperature and humidity part. And as you can see beside the code, there's a diagram for you to refer on which wire it is connected to and which pin it is connected to. So without further ado, let me start explaining the code. So firstly, of course, we need to declare the temperature sensor pin, light sensor pin, and all the LEDs as well as the um, button pin, where the temperature sensor pin will be connected to A0, light sensor pin will be connected to A1, yellow LED will be connected to number 2, green LED pin to number 3, red to number 4, and the motor pin to number 5. And lastly, of course, the button pin will be connected to number 6. For the second part, what we need to do is to initialize all the LED pin to low, which indicates that the LED will not light up unless it turns into high, which shows that the LED will light up when the code turns to high. And of course, also we need to run the LED test to ensure that the lights will turn on once the code is run. And as for the last part, where you can see that we created a void loop to separate or segregate what happens basically when the temperature is below 25 degree, which indicates it is cold and the fan will spin slowly, but also it will slowly increase in accordance to the humidity. And as for the temperature for between 25 to 35, which indicates hot, medium hot temperature, will make the fan spin quite fast, but will increase with according to the humidity. And lastly, if the temperature is very hot, which is above 35 degrees Celsius, the fan will spin very fast and will also increase with humidity. And before the if loop, what we need to do is to initialize a few variables such as reading, integer reading, float voltage, and float Celsius. And of course, somehow we somehow need to convert the raw value to Celsius and the raw soil moisture to the value needed. So that's why there's a mathematical coding on the initialized part so that the code can read the values properly. And that's all for my part.
Hello, my name is Muhammad. Then I will explain about the comfort response system, which is code line 145 to 228. This section of program is designed to control the fan speed, LED indicator, and LCD display based on two factors, which is temperature and humidity, where the humidity is measured indirectly using the soil moisture sensor value, which is raw soil moisture value. The logic is divided into three temperature range, and each temperature range have three humidity range. When the temperature below the when the temperature below the 25 degrees Celsius but above 0 degrees Celsius, the fan spins slowly but increase slightly depending on the humidity. If the humidity value less than 300, indicating dry condition, the fan speed is set to the 60 and the yellow LED turn on. While the moderate humidity, which is the value in between 300 to 700, the fan set to the 120 and the yellow LED is still turned on. And the indicator and it will display humid for the moderate humidity. And for the high humidity, which is 700 above, the fan set to the 118 and the green LED will turn on. And for this condition, it will display humid plus. Next, for the temperature between the 25 degrees Celsius to 35 degrees Celsius, the fan runs faster due to the warmer condition. For the dry air, the fan speed set to the 100 and the green LED turn on. For the moderate humidity, the fan set to the 160 and the green LED is turned on. For the high humidity, the fan speed set to the 220 and the red LED is turned on. Lastly, for the very hot temperature above 35 degrees Celsius, the fan runs at high speed regardless of the humidity. Dry air runs at 200, moderate humidity runs at 230, and the high humidity, the maximum fan speed run at 255. And for this, all the LED, the red will turn on. As you know, the as you know, LED serve as quick indicator, yellow for the cool and dry, green for the comfortable or humid cool air, and the red for hot and uncomfortable condition. And for the LCD, provide a text description of the humidity level, ensuring that the system reacts realistically to the heat fed by the adjacent fan speed according to the both temperature and humidity. That's all for my part.
Hello, my name is Muhammad Hilmi, and for the project, In this section, I worked on integrating and calibrating the light sensor and then creating the logic for the automatic lighting control. S- Um, so firstly, let's look at this first piece of code, which basically reads the light sensor value and converts. So we take this raw light value, which is a new variable, and then we read the analog signal from the light sensor pin, which was another variable already declared earlier, which is read from the A1 input on the Arduino board. And the function below it stores the raw light value multiplied by 0.0976, which is a conversion factor from the 10-bit number and the analog signal, and stores it in the value called light.
Alright, now I will explain the manual and automatic lighting control part of our system. This section controls the white LED, which acts as a room light. It can operate in two modes: automatic mode based on ambient lights, or the manual mode where we control the brightness ourselves. Okay, so we're gonna jump into the mode detection. The Arduino checks the position of the mode button connected to pin 7. If the button is low, which is 0, it runs in auto mode, and if the button is high, it runs in manual mode. This is shown on the LCD in the bottom right corner here, manual or auto. In the auto mode, the white LED changes based on the light sensor reading. The light sensor converts the raw analog value into percentage light scale. So here in the code, we set dot is below 20 and the percentage is below 20, and the raw analog value is 255, which is dark, and then 20, which is between 20 and 34. The light is set to dim, 100, and then lastly the bright, which is more than 35. It's set to 0, which is bright. In manual mode, the LED brightness no longer controlled by the sensor. Instead, the potentiometer is connected to the pin A3. This is pin to set the brightness. The reading from potentiometer is mapped from 0 to 1023, 0 to 1023, and 0 to 255. The LCD still shows light condition, which is dark, dim, or light, but the LED intensity depends on our knob position. If the light sensor is disconnected or reads 0 in both modes, the system keeps working but only shows sensor-based levels if valid data are present. In short, the auto mode reacts to the environment automatically, while the manual modes give full user control over the lighting level. So, we're gonna start the demonstration with the auto mode. So this is the light sensor right here, the ambient light sensor. If I control over here, you see this light is gonna become dim, and if I max out the light, it becomes dark. And if I give it no light, oh sorry, if I give it, this one is bright right here, and if I put it right here, it becomes dark. Alright, so now I'm going to show the manual mode. So for the manual, you're going to control using this potentiometer right here. So it's still going to show the dark here. This is going to still pop up, but we can change it here, and you can see it will change. See, it will change. The color of the light bulb will change. Alright, so that's it from me. Thank you.
Hello, I'm back again. So now we are going to do the final demonstration of the Arduino, our Arduino project. So here we have the motor powered by an external power supply, as Arduino do not have enough voltage to power it. Now we have the switch, we have the LED as our first order for light. We have potentiometer here as our manual control for light, and then we have ambient light sensor to automatically control our light. And then we have temperature sensor here, LEDs to show hot, comfortable, and cold. And it is our humidity sensor. And then it is the LCD will display information there. So now I will start the simulation. So according to our code, we begin the setting up to check if every component is working perfectly. So now everything is blinking all right. So now we see that the blue LED is blinking, which means that something is broken. But we just set according to our code, we set it to 0. Our sensor, if it's 0, we will assume it's broken, as our ambience and humidity sensor is 0 right now. So it will show that this LED will show if something is broken. So now you can see here from the LCD, you can see that the it is broken, so we can know which one is broken, which sensor need replacement. So right now it is for light and it is for humidity. Now let me increase we will now test the manual and automatic light lighting system. So now as we can see here is manual, which means we will use the potential meter to control our lighting. So we can look at it here. I will turn this off now. See, it's not lit at all. So if we use this potentiometer, we can increase it slowly. Here, can now achieve maximum brightness of the LED. So now, what if we use the automatic one? We will turn on the switch and set here automatic. And we'll use our ambient light sensor to control the. You see here it is very dark, so it is burning. It's bright. Now we turn it to light. Here, so here it's dark. Now we turn it on in the middle with dim. So this also get dimmer, right? But now we get a very bright light condition. We see here bright, and then the LED will turn off. Now that's it. That's for the automatic and manual lighting system. So next we will be showcasing the our humidity and temperature, and then our motor. So as of now, it's broken here. We now adjust it to we now adjust the temperature to lower than 25 to 19. And then this one very low, which means dry. So you can see here it is dry, and then you can see here with 19 degree 19 degrees Celsius and very dry, and we show that our surrounding heat is cold. And then while our fan or DC motor will spin slowly, it's like lowest. Then I will increase the humidity to medium. It is the same. But you can see here it's humid, do the same function and steam. It's increase not steam but increase motor speed a little. And then as we increase the humidity, it's humid plus, right? When our cold, very cold temperature, humid at a scale, we are now in a comfortable region. Our and as our fan will spin faster. Now if we get to 25, select the medium setting, as will reset it and say dry, but because 25 like comfortable for us, the green early will show up. Then if dry, same with our fan, it's low right now. Yeah, we're not just the humid, let's say humid, yeah, but still because of the combination is still fine, comfortable for us, and the for the code, the system motor also get faster. And then finally, we went plus. You see because of the combination of humid and temperature, we get hot for us. So now the red LED will on, and the system motor will spin faster now. So now if we get into above 35 degree, which is very hot, our orange red, and LED will turn on despite our humid setting because it's very hot. Here it's dry, hot, and then our fan also is spinning quite fast. But as they get more humid, I get more humid here, spinning with very faster. Finally, very humid plus where the fan will spin the fastest. Okay, I think that's all from this demonstration. Thank you for the attention.